This is a gravity and satellites question. I've already written it up there. So before the spacecraft Apollo 11 landed on the moon, it travelled around the moon with an orbital period of 2 hours. It's T. Now when we go to do calculations, that's not the unit we wanted in. We wanted in seconds. And in 1 hour, 60 minutes and 60 seconds. So the time in this case is twice that. So there's our time period we need to use. Calculate the height of Apollo 11 above the moon's surface during its orbit of the moon. Take the orbit as circular. Alright, so what we're going to do is, here's the moon, and the satellite goes around this. If we can work out the radius of its orbit, and we already know the radius of the moon, we can work out its height by subtracting one from the other. So we're going to work out this guy here, the radius of its orbit. And to do that, this is one of the formulas we've got ready on our cheat sheet, because we did all the rearranging of it in class and don't have to spend time rearranging it here, but it's ready to go. So third square root of GMT squared over 4 pi squared, which in this case equals the third square root of G is 6.67 by 10 to the minus 11 by the mass of the moon is here 7.36 by 10 to the 22. The time period is what we worked out there, 7,200 squared over 4 pi squared, cube rooted of all that. On other videos I've gone through, because most people make the mistake of typing it in their calculator. So the answer for that all in one go is 1861099 meters, which is 1.86. Oh no, sorry. Which equals 1.86 by 10 to the 6. That's this radius here. If you want me to go through how to do this on the calculator, check out the 2011, 2010 and maybe even 2009 where I've gone through it step by step to try and practice to make sure you get it right on your calculator. But basically I do the top first, push equals, and then divide it by the bottom in brackets, push equals, and then cube root the entire answer. So I do it in 3 steps. This is giving me the radius, which is this number here. To find the height, I've got to do the full radius, which is what I've just worked out, 1.86 by 10 to the 6, and minus the radius of the moon or the planet, 1.74 by 10 to the 6, minus 1.74 by 10 to the 6, and once I've subtracted them I get 0.12 by 10 to the 6, which equals 1.2 by 10 to the 5. So I got a bit ahead of myself there. 1.2 by 10 to the 5. Alright, that's why it's the big one, 4 marks. Explain the terms weightlessness and apparent weightlessness and identify which best applies to the astronauts during the moon, orbit of the moon. Alright, so weightlessness is completely outside a gravity field. Completely outside a gravity field. And apparent weightlessness is equal, what is that? It's when the normal force equals 0, but gravity force is still present. The only force on these astronauts in the in this Apollo 11 module will be the gravity force. So the apparent weightlessness applies to them. Applies to this case.